So up to now, we've dealt with angles of 30, multiples of 30, 45, or 60. 210 degrees, multiple of 30. 180 degrees, multiple of 60, and also 30. But there's other measures and other numbers that are not a multiple of 30 or 60 or 45. So that's what we'll be dealing with today, is multiples or measures or trig ratios of angles that are not multiples of 30 or 60. For example, the sine of 13 degrees. Okay, sine of 13 degrees. There is no relationships that we can come up with the 13-degree angle for a right triangle, a 1377 degree right triangle. There's no relationship between the sides, where if you have a 30-60 right triangle, the hypotenuse is always twice the length of the shortest leg. And a 45-45 right triangle, we have the legs are going to be congruent. So we can come down with values with respect to those triangles. But when I'm dealing with a 13-degree angle, there is no relationship that says that one leg is going to be a multiple of another leg or the hypotenuse for a 1377 triangle. But we still have triangles and angles that will measure to 13 degrees, and we're going to need to be able to find these trig ratios. Well, back in the old days, you had just to deal with the back of your book to be able to find these trig values. But now with the use of your calculator, or your calculators make things a lot easier for you. Where first off, we need the KYC, know our calculator. Okay, I need you to hit the mode button, which is right beside the blue button up top. Hit your mode button. And the third line down on the mode button, you have radian and you have degree. What you need to make sure of is that degree is highlighted. If the radian is the one highlighted, okay, if this is highlighted, you need to go down to that row, hit your right button, go over top degree and hit enter, and now degree is highlighted. Okay, that's changing your mode from radians to degrees or degrees to radians. We'll eventually deal with the idea of radians here. Okay, but for right now, we'll just deal with degrees. So what we're able to do, how we can get out of this, we get hit our second button, hit the mode button again, that just quits us out of there. Okay, quits us out of there. We can clickety-clack into our calculator the sine of 13 degrees. I always close my parenthesis out. Well, we just type it in and we can hit enter, and it comes up with the sine of 13 degrees. Now, when dealing with sine, cosine, and tangent, most of the time these are going to be irrational numbers. These are angle or numbers that will never, they're decimals, bless you. These are decimals that will never terminate or never repeat. So we come down to 0.2249510.543, but this will continue on indefinitely. Okay, so what do we do? How do we deal with this number? Well, typically we will take 4 digits and round to the 4th digit. So we have 0.2250. Once again, we can just get that off the calculator. Well, when we're dealing with minutes and seconds, okay, we're dealing with minutes and seconds. I have 39 degrees, 13 minutes. I want to find the measure of the tangent of this angle. Well, when we're talking about parts, or when we're talking about minutes, we're talking about parts of an angle. We're talking about the parts of an angle. Well, if we have a pizza that's cut into 4 pieces, and we ate 3 of the 4 pieces, what part of this pizza did we eat? 75. 75 what? 75%. How'd you get 75%?
Well, 1 whole is 1. We ate 3/4 of it.
Okay. We ate 3/4 of that. So we ate 3 the part of the pizza that we ate over our total amount, which was 4. So we were able to take this as 0.75 or then change it into a percent, 75%. So we took the part over the entire. Well, when we're talking about minutes, that is parts of a degree. Okay, 13 minutes is a part of a degree. Well, what's an entire degree in minutes?
60.
60. So we can talk about this part over the entire. So this is the tangent of 39 degrees plus 13 over 60. Because we're adding 2. This is the part over the entire. So what I can clickety-clack into my calculator is I can type that in as is. I can type in the tangent of 39 plus 13 divided by 60 and then close your parenthesis out. Zach, what do you come up with?
0.8160.
8160? Go with that. Once again, go to 4 decimal places. Go to 4 decimal places and you're fine. What did you get?
81123.
81123. You got that?
Here, look. Mark that. Oh, no, I got it.
Yeah.
Oh, no.
So when we're dealing with minutes, we can just put it in over 60, your minutes over 60, and click it into the calculator. Once again, your calculator will follow your orders of operations for you. So you don't have to worry about doing anything special. You don't have to put 13 divided by 60, get a decimal value of that, and then take 39 point whatever. You can type it in as is. Okay, don't make your life more difficult. Well, what happens if I have the secant of 59.2 degrees? Well, on your calculator, you have a sine button, you have a cosine button, you have a tangent button. If you sit there and try to find the secant, cosecant, and cotangent, you would eventually be able to find it somewhere in a catalog. But to me, that's more work than you need to do. Because we have properties of reciprocal functions. We have the cosecant of theta is defined to us as 1 over the sine of theta. We have the secant of theta is 1 over cosine of theta. We have the cotangent of theta is 1 over the tangent of theta. These are what we defined last week as the reciprocal functions. These are definitions. If these are definitions, we can go back to them and utilize them. Well, what I'm given here is I'm given the secant of 59.2 degrees. We want to write this in terms of sine and cosine or tangent. How can we rewrite the secant of 59.2 degrees in terms of sine, cosine, or tangent? Well, look at your definitions. How can we rewrite it? You're close. You're really close. It's not the cosine of 1 divided by it, but if I look at the secant of theta, theta represents, it's a variable that represents the angle. This is equal to 1 over the cosine of that exact same angle. So what I suggest that you do is first rewrite as, by definition, secant of theta is 1 over cosine of theta. Well, our theta value here is 59.2 degrees. So we can rewrite this as 1 over the cosine of 59.2 degrees. We are just using our definitions. We're using our definitions. So now in my calculator, I can clickety-clack through 1 divided by cosine 59.2 degrees. Close your parenthesis out. Hit enter. Rachel, what do you come up with? 1 point what? 9529. Good with that? All right, 1.599529. All right, let's go to the cotangent. 71 degrees, 32 minutes. Now you're combining both of these ideas here. First, rewrite as its reciprocal function. Rewrite as its reciprocal function. Cotangent, I don't have a cotangent button, but we can rewrite it as 1 over what? And just rewrite it. Don't try to do too many things of just remembering what's going to happen. Because if you try to do too many things about what is remembering what you have to do, you won't be able to remember it. Once again, that goes into short-term memory. Goes into short-term memory and it'll be gone. So rewrite it and then calculate it. And check your answer with somebody around you. Once again, utilize the last two things that we just did here. I can rewrite with this, but how do I deal with the minutes? Well, I can rewrite it up here. How do I deal with minutes? Okay, the 32 minutes, how do I deal with that? Check your answer with somebody around you. Should be able to rewrite 1 over the tangent of 71 degrees plus the 32 divided by 60. Owen, what do you come up with?
13340.
13340. Good with that? Once again, need to write these steps out because we are reciprocating here. And what I'm going to do is I'm going to put the process in reverse, and it's going to be confusing to you if you're not writing things down. Okay, we're going to look at inverse trig functions. Mathematics. In mathematics, why people like mathematics is because there's definitions to processes. There's a process to be able to go through, just like there was a process to find the cotangent at 71 degrees, 32 minutes. There's a process that you can work yourself through. Okay? But for every process that you can work yourself through, we have to be able to undo that process mathematically. So every process we do, we need to mathematically have a definition to undo that process. What I dealt with the first part here, we are finding trig values. We are finding trig values. Now we're going to find the inverse trig value, which is undoing what we just did. It undoes the trig function of an angle. It solves for an angle. So there's two things that this deals with when you're dealing with an inverse trig value. It undoes the trig function of an angle. It solves for an angle. We did the process up top. We want to be able to undo that. We want to be able to go back to where we began with. If I would square the value of 5, we would get 25. To undo that process of squaring it, we take the square root of it. Square root of 25 takes us back to 5. If I take the log of a value, I come down to an answer. I can take that answer and use that as an exponent of 10 to go back to my original problem or value. Well, on your calculator is set up nicely for you, where if you take a look at the sine, cosine, tangents, or anything on here that you're dealing with operations, and look at your second function, which is the function right above the button. If I take the sine of an angle, if I look above the sine button, I have what is called an inverse sine. It undoes it. Above the cosine, we have the inverse cosine. And above the log button, we have 10 to the x power. That undoes it. Above the square button, we have the square root button. So this undoing process is set up in your calculator to be the second function. Once again, you're solving for an angle. So whenever you take the inverse cosine of 0.432, we can clickety-clack into our calculator, inverse cosine, so I use my second button, my cosine button, 0.432, and hit my enter button. What this will do is this will give you an angle, some angle measurement. And then that angle measurement, if I would take the cosine of that angle measurement, I would go back to 0.432. So if we take the inverse cosine of 0.432, what is our degree measure? Addie, what do you get?
64.41.
64.41 degrees. Go with that. If you would take the cosine of that angle, you'll go back to 0.432 or close to it. Won't be exact. Inverse tangent, I'm 1.32. Once again, you're finding an angle, the measure of an angle. Vic, what do you come up with?
52.85.
52.85. So if I would take the tangent of 52.85, I'm going to get approximately 1.32. It's not going to be exact. It won't be exact, but it'll be close. Once again, the processes are doing and undoing of each other. Well, the work we have to deal with here is now we can now solve equations using trig functions. I have the sine of theta is equal to 0.857. If I gave you the equation 2x is equal to 12 and I asked you to solve that equation, Trent, what would you do? Divide by 2. Because the process that we have there is we're multiplying by 2. To undo the multiplication by 2, we divide by 2. So x is equal to value 6. If I have x squared is equal to 36, and I want to solve this equation, x squared is equal to 36, what would we have to do to both sides to be able to solve this equation? How do I get rid of my square? Square root. So x is equal to value 6. We are trying to undo the process of what we have there. We have the square button, so we take the square root. It undoes the process. We have multiplication by 2. We divide by 2. It undoes the process. Well, now I'm asking you the sine of theta is equal to 0.857. I want to solve for theta. So the process that we're doing, we want to get theta by itself. We have the sine that's attached to it. We want to get rid of the sine. We want to get rid of the sine. So what do we have to do to both sides of our equal sign to get rid of sine? Inverse sine. We don't divide by sine because that's a common thing that we put in our brain because we're so used to 2 times x, 2x is equal to 12. We have to get rid of multiplication, so we divide. So you sit there and say, well, I have the sine of theta. I need to get rid of multiplication by sine. Sine is not being multiplied here. We have to take the inverse sine to get rid of the sine. The inverse sine gets rid of the sine, just like the square root gets rid of the square. But what I do to one side, I do to the other. So we have the inverse sine of 0.857. So I can clickety-clack into my calculator, inverse sine of 0.857, and hit my enter button. Kaylee, what did it come up with?
58.98.
I'm sorry,
58.98.
58.98. So if I would take the sine of that angle, I would get something close to 0.857. Once again, the undoable process here. Well, what happens if I have a secant? Well, if we follow the same method of madness, we take the inverse secant of 1.75. The problem we run into is we don't have an inverse cosecant button on our calculator. So we have to do some additional steps. And it's just like if I gave you the equation 2x plus 7 equals 9. This was a two-step equation. We had to subtract 7 from both sides and then divide by 2. That's the same thing that we had to deal with up here. We have a couple steps that we have to worry about because we don't have an inverse secant button on our calculator. But we can rewrite secant of theta as its reciprocal function. What's the reciprocal for the secant of theta? Kendall? Cosine. So we can rewrite this as 1 over cosine of theta is equal to 1.75. Why? Because by definition, secant is defined to us as 1 over cosine of theta. Need to write these steps out so it goes back into our longer term memory rather than just saying, oh yeah, and do some Sandlot learning here. Yeah, that's how you do that. Oh, yeah, I got it. At this point, we want to deal with this. We can reciprocate both sides. We can flip both sides. So we can rewrite this as the cosine of theta is equal to 1 over 1.75. Yes, this would be over 1. Flipping this side, it would be over 1, but we don't need that 1 there. So now I have cosine of theta equals 1 over 1.75. Need to solve for theta here. So what do we have to do both sides to get rid of the cosine of theta? Gavin, what do we have to do to both sides to get rid of the cosine of theta?
You multiply both sides by cosine of -1.
I'm going to eliminate that word multiply. We're just going to take the inverse cosine of both sides. We're going to take the inverse cosine. Just like here I have x squared is equal to 36. We took the square root of both sides. We're going to take the inverse cosine of both sides. So I have inverse cosine of 1 over 1.75. You can click and clack that straight into your calculator. Inverse cosine of 1 divided by 1.75. Close your parenthesis out there.
55.15.
55 point what?
15.
15. This will be a type of problem that you're going to be given on the homework. Okay, you're going to ask the inverse cosecant. What I suggest you do to get rid of inverse cosecant, we can take the cosecant of both sides. So we can rewrite this. Cosecant of theta is equal to 1.32. Okay, rewrite cosecant of theta as its reciprocal function. Cosecant of theta is 1 over what? Okay. We can rewrite this as 1 over sine of theta is 1.32. Flip both the sides. We're just following the same method of madness we just did above. flip both of your sides. So we have sine theta is equal to 1 over 1.32. This is over 1. And then we can take our inverse sine of both sides. What do we come up with? Anybody? Look at Zach.
49.25.
Last type of problem you're going to run into. Okay, sine of theta is equal to 0.521. I want to find the tangent of theta. Like what we did today. I gave you the quadrant and a ratio. I want to find the other ones, but we're going to change our measures here. We want to deal with this first and determine what theta is. I have the sine of theta is equal to 0.521. I'm going to solve for theta. What do we have to do to both sides to solve for theta, Maddie? As sine of theta is equal to 0.521, what do we do to both sides? How do I get rid of the sine? Not reciprocal. Sine of theta is equal to 0.857. How do I solve for theta? What do we do?
Do like the opposite one, sine minus.
Okay, that's called the inverse sine. So we have inverse sine of 0.521. I can click that into my calculator, find what theta is. Inverse sine 0.521. London, what do you get?
31.39.
31.39. Good with that? Okay, so now I want to find the tangent of this angle. So I'm going to click into my calculator, the tangent of 31.39. Once again, two-step process here, not just one step. What we get? Anybody? 0.6 what? 0.6101. Homework tonight's on page 23, 3 to 30, multiples of 3. Page 23, 3 to 30, multiples of 3. Again, that's on Classroom. If you want to look at Classroom, that assignment is there for you. Questions you have? I think the bells are off again today. Adios. Have a good day.
I was absent yesterday. Can I come in?